A rancher in South Dakota just tripped over something that shouldn't exist. Buried 3 feet under his cattle pasture, archaeologists found a stone tool lodged in a mammoth rib, dated to 12,900 years ago. That's not the weird part. The weird part is what was lying next to it. A layer of black sediment filled with microscopic diamonds, platinum anomalies, and enough evidence of cosmic impact to make every textbook from the last 80 years look like fiction. So what actually happened at the end of the Ice Age? Because apparently, for decades, the story of how humans came to North America was settled science. The Clovis people, named after stone tools first discovered in Clovis, New Mexico in 1929, were the first Americans. They walked across the Bering Land Bridge from Siberia around 13,000 years ago, following giant mammals into a pristine, uninhabited continent. They hunted mammoths and mastodons with distinctive fluted spear points. They spread across North America in just a few centuries. End of story. Case closed. That's what we were taught in school. Except it was never that simple. Even back in the 1970s and 80s, archaeologists kept finding sites that didn't fit. Campsites in South America that predated the supposed migration. But the academic establishment had invested so much in the Clovis first model that contradicting evidence got dismissed, ignored, or explained away. Carers were destroyed over suggesting that maybe, just maybe, people got here earlier. Then came the genetic evidence. DNA studies in the early 2000s showed that Native American populations had way more genetic diversity than you'd expect if everyone descended from a single migration 13,000 years ago. The timelines didn't match. Population genetics suggested people had been in the Americas for at least 15,000 to 20,000 years, maybe longer. But it was the archaeology that really blew things apart. In the last 20 years, site after site has been discovered and properly dated that predates Clovis. Monteverde in Chile, dated to 14,500 years ago. The Buttermilk Creek Complex in Texas, possibly 15,500 years old. Cooper's Ferry in Idaho, showing human occupation 16,000 years ago. The Clovis first model didn't just crack, it shattered. This discovery in the Great Plains is taking everything we thought we knew and throwing it into chaos. And what happened to the world they lived in? The site in question is in western South Dakota, not far from the Black Hills. A rancher, let's call him Jim because I'm not using real names without permission, was installing fence posts in 2024 when his auger hit something hard. He figured it was a rock, kept digging, and pulled up what looked like a massive bone. Being a smart guy who watches too much YouTube, he called the local university instead of mounting it on his wall. What the archaeologists found when they got there made them cancel their other projects for the next year. The bone was a mammoth rib, but it had a stone projectile point embedded in it. Not lying next to it, not nearby, actually stuck in the bone. This was a kill site. Someone had hunted this mammoth successfully, and the animal had either died there or died nearby and been butchered on that spot. They dated the bone using radiocarbon dating. 2 plus or minus 50 years. Right at the end of the Pleistocene, right at the transition between the Ice Age and the modern climate. That date is significant for reasons we'll get to in a minute. The projectile point itself was interesting. It wasn't Clovis. Clovis points are distinctive. They're fluted, meaning they have a channel running up the center where a flake was removed to help with mounting on a spear shaft. This point was different. Simpler, cruder, but effective. It had done its job. It had killed a mammoth. But what got the archaeologists really excited, what made them start making phone calls to colleagues around the world, was what they found in the layer of sediment directly above the mammoth bone. A black mat. That's the technical term. Usually rich in carbon, that appears at sites all across North America at approximately the same time. They found things that shouldn't be there. Microscopic diamonds. Not the kind you'd put in an engagement ring. Nanodiamonds. Tiny crystals that form under extreme heat and pressure. The kind of heat and pressure you get from cosmic impacts. They also found high concentrations of platinum and iridium, elements that are rare in Earth's crust but common in asteroids and comets. They found magnetic spherules, tiny balls of melted rock that form when material is heated to extreme temperatures and then cools rapidly in the air. All of this pointed to one conclusion. Something from space had hit Earth, right around the time that Mammoth died. This ties into something called the Younger Dryas impact hypothesis. The Younger Dryas was a period of sudden dramatic climate change that happened around 12,800 years ago. The Earth had been warming up coming out of the Ice Age. Glaciers were melting, sea levels were rising, vegetation was changing. And then, suddenly it got cold again. Really cold. Temperatures dropped by as much as 27 degrees Fahrenheit in some regions. Almost overnight in geological terms. This cold snap lasted for about 1,200 years before warming resumed. It's called the Younger Dryas, after a flower, Dryas octopetala, that thrives in cold climates. When scientists analyzed pollen from sediment cores, they found this flower appeared suddenly in places it hadn't been before, indicating a rapid return to Ice Age conditions. The question was always, what caused it? The most popular theory involved the melting glaciers. As the massive ice sheets covering North America melted, they released enormous amounts of fresh water into the ocean. This fresh water disrupted ocean currents, particularly the Gulf Stream, which carries warm water from the equator up to the North Atlantic. When the Gulf Stream weakened or shut down, Europe and North America got colder. Fast. That theory made sense, and there was evidence for it. But it never fully explained some of the other things that happened at the same time. Like why dozens of species of large mammals went extinct right around 12,800 years ago. Mammoths, mastodons, giant ground sloths, saber-toothed cats, dire wolves, short-faced bears. That's not a gradual die-off. That's a catastrophe. The traditional explanation was human hunting. The Clovis people arrived. They were efficient hunters. They killed off all the megafauna, except the timeline never quite worked. Some of these animals went extinct before Clovis appeared in some regions. And in other parts of the world where humans arrived, like Australia, the megafauna extinctions happened thousands of years earlier or later. It wasn't a consistent pattern. Across North America, in the sediment layer from 12,800 years ago, there are signs of widespread burning, charcoal, ash, changes in vegetation. Something burned huge swaths of the continent at the same time. The Younger Dryas impact hypothesis, first proposed in 2007 by a team of scientists led by Richard Firestone, suggested a different explanation. What if a comet or asteroid had broken up in Earth's atmosphere and created multiple airbursts and impacts across North America? The heat from the airbursts would ignite massive wildfires. The impacts would throw debris into the atmosphere, blocking sunlight and triggering the climate cooling. The shock waves and thermal radiation would kill animals over huge areas. It would explain everything. The problem was proof. If something big enough to cause global climate change had hit Earth, where's the hole? Impact craters are hard to miss. The one from the dinosaur-killing asteroid 66 million years ago is 93 miles wide, and we found it under the Gulf of Mexico. So where's the Younger Dryas crater? The answer might be that there isn't one. Not every cosmic impact leaves a crater. If a comet broke up high in the atmosphere, you'd get airbursts, like the Tunguska event in 1908 in Siberia, where an object exploded in the air and flattened 770 square miles of forest without leaving a crater. Multiple airbursts across North America would cause devastation without a single impact site. Or the impact could have been on the ice sheet. The Laurentide ice sheet covered most of Canada and parts of the northern United States 12,800 years ago. If something hit the ice, it would melt enormous amounts of ice instantly, releasing that fresh water into the ocean that I mentioned earlier. It would also explain why we haven't found a crater. It melted and the evidence flowed into the ocean. This hypothesis was controversial. Many mainstream scientists rejected it, saying the evidence wasn't strong enough. But then sites started piling up. Not just in North America, but around the world. Black mats with nanodiamonds, platinum anomalies, magnetic spherules, all dated to the same narrow window around 12,800 years ago. Syria, Mexico, Chile, even Antarctica. Whatever happened, it wasn't local. It was global. And now this site in South Dakota adds to that evidence. The black mat directly above a mammoth kill site, dated to exactly the right time period, containing all the markers of a cosmic impact. It's not proof by itself, but it's another piece of a very large puzzle. Here's where it gets personal for the people involved. The archaeologists working this site aren't just digging up bones and measuring things. They're dealing with what this means. If the Younger Dryas impact hypothesis is true, It means that human civilization, the one we know, almost didn't happen. Think about it. 12,800 years ago, humans in North America were thriving. They'd adapted to the Ice Age environment. They were hunting megafauna successfully. They had stable populations. Then something from space exploded over their heads, set the continent on fire, killed most of the large animals they depended on for food, and plunged the world back into deep freeze for over 1,000 years. The human population in North America collapsed. The archaeological record shows it clearly. Sites from before the Younger Dryas are relatively common. Sites during the Younger Dryas are rare. People survived, obviously, but their numbers dropped dramatically. Some regions were probably completely abandoned. The Clovis culture, the one we thought was first, actually appeared after this catastrophe, around 13,000 years ago, just before the impact. When sites appear again around 12,500 years ago, the tool technology has changed. The fluted points are more refined. The hunting strategies are different. It's like the culture had to rebuild itself from scratch. This also explains something that never made sense about the megafauna extinctions. Why did so many species go extinct in North America but not in other parts of the world? Africa had plenty of large mammals, and humans had been there way longer than in North America. Why didn't African elephants and rhinos go extinct? Because whatever hit North America hit it hardest. The airbursts, the wildfires, the climate effects. They were most severe in the Northern Hemisphere. Now let's talk about what was found alongside that mammoth bone. The excavation is ongoing, but so far they've uncovered evidence of a hunting camp, stone tools, fire-cracked rocks from a hearth, the remains of other animals that were probably also hunted. But they've also found something unexpected. Seeds and plant remains that suggest these people weren't just hunters. They were using and possibly managing plant resources. This challenges another assumption. We've always thought of Paleo-Indians, the ancient people of the Ice Age Americas, as pure hunters, following the herds, living a nomadic lifestyle, focused entirely on big game. But the evidence from this site and others like it suggests they had a more complex subsistence strategy. They hunted, yes, but they also gathered, fished, and used plant resources extensively. Why does this matter? Because it means these people were more sophisticated than we gave them credit for. They weren't just killing whatever they could find, understanding plant cycles, probably returning to the same locations seasonally. They had deep ecological knowledge, and then it all got wiped out. The cosmic impact, the fires, the climate collapse. Imagine being one of those people. You've lived your whole life in a world that, while harsh, is predictable. You know where the herds migrate. You know when the plants fruit. You know where to find water. And then one day, the sky explodes. Fire rains from above. The animals you depend on start dying. The plants wither. The climate shifts. Everything you knew becomes useless. The survivors would have had to adapt fast. The camps from after the Younger Dryas showed different patterns. Smaller groups, more mobile, focusing on smaller game. You can see it in the tool assemblages. Fewer large spear points, more small projectiles, more emphasis on processing plants and small animals. There's also evidence of population bottlenecks in the genetic data. Native American populations show signs of having gone through a severe population reduction sometime in the distant past. The timing matches the Younger Dryas. This wasn't just a cultural disruption. This was a brush with extinction. But here's the thing that makes this discovery in South Dakota so important. It's giving us a direct link between the cosmic impact evidence and human occupation. Previous sites had one or the other. Black mats with impact markers, but no clear human presence. Or human sites from the right time period, but no impact evidence. This site has both in direct association. The people who killed that mammoth died, or left right around the time of the impact. We're seeing the before and after in the same location. The analysis is still ongoing. They're using every technique available. Ground-penetrating radar to map subsurface features without excavating. Soil chemistry to understand the environment. Isotope analysis on the bones to determine what the animals were eating and what the climate was like. Ancient DNA extraction to see if they can get genetic material from the humans who were there, though that's a long shot given the age and conditions. They're also looking for more impact evidence. Microscopic diamonds are just one marker. They're testing for shocked quartz, a type of quartz crystal that's been deformed by extreme pressure, the kind you only get from impacts or nuclear explosions. They're looking for glassy particles called spherules that form when rock melts and cools rapidly. They're checking for helium-3 isotopes, which are more common in space materials than Earth materials. Every test that comes back positive makes the cosmic impact hypothesis stronger, and so far, most of them are coming back positive. This also has implications for how we think about catastrophes and human resilience. But the Younger Dryas impact, if it happened the way the evidence suggests, shows that progress isn't guaranteed, can be set back dramatically by events beyond their control, and ecological knowledge built up over thousands of years. The survivors had to start over in many ways. Knowledge was lost. Population dropped. It probably took centuries to recover. And yet they did recover. By 11,000 years ago, human populations in the Americas were growing again. New tool technologies were developing. People were spreading into regions that had been uninhabitable during the Younger Dryas cold period. The megafauna were mostly gone, so they adapted, hunting smaller game, relying more on plants, eventually developing agriculture. That's the resilience part. Humans are remarkably good at surviving catastrophes. Not all catastrophes, obviously. But even something as devastating as a cosmic impact and the subsequent climate collapse didn't wipe us out. We survived, adapted, and eventually thrived again. The researchers working on the South Dakota site are careful not to overstate their findings. Science requires caution, especially when you're challenging established models. Many of them believe this is a turning point. The evidence for the Younger Dryas impact is mounting. It's not a fringe theory anymore. It's becoming the mainstream explanation, which means all those textbooks that talk about Clovis first and gradual climate change at the end of the Ice Age, they're already out of date. The story is more dramatic, more catastrophic, and more interesting than what we've been teaching. There's also ongoing work to figure out exactly what hit us. Was it a comet? An asteroid? How big was it? Where did it come from? Some researchers think it might have been part of a larger object that broke up in the inner solar system thousands of years earlier, with fragments hitting Earth periodically. The Younger Dryas impact might have been just one piece of a larger bombardment that happened over centuries. That's a scary thought, by the way. That objects big enough to cause global catastrophes might still be out there, in orbits that occasionally bring them close to Earth. We're getting better at tracking near-Earth objects, but we haven't cataloged everything. Something could be headed our way right now and we might not know until it's too late. But let's get back to the archaeology. The team in South Dakota is planning to expand the excavation next summer. They want to open up a larger area, see if they can find more kill sites, more evidence of the camp, maybe even burials. Burials from this time period are incredibly rare in North America. If they find one, it would be a major discovery on its own. They're also working with other research teams around the world who are investigating Younger Dryas sites. There's a site in Syria where similar black mat deposits have been found in association with human occupation. There's work happening in Mexico, Chile, and Antarctica. All of it is pointing to the same conclusion. Something happened 12,800 years ago that affected the entire planet. But it's a compelling piece. It shows humans were here. They were thriving. And then something dramatic happened. The layer of black sediment with its cosmic markers tells a story of fire, one of abandonment or death. This discovery won't settle all the debates. Science doesn't work that way. There will still be skeptics who want more evidence, who argue about the dating or the interpretation of the impact markers. That's fine. That's how science is supposed to work. But the weight of evidence is shifting. What seemed impossible 20 years ago, that a cosmic impact nearly wiped out early Americans, is now looking more and more likely. And that changes everything. It changes how we understand the peopling of the Americas, the extinction of the megafauna, the development of early cultures, and the resilience of human populations in the face of catastrophe. It's not just ancient history. It's a reminder that we live on a planet that's vulnerable to cosmic events, and that human civilization, as advanced as we think we are, could face similar challenges. The rancher who found that mammoth bone, by the way, is still running cattle on his land. The archaeologists filled in the excavation pit and promised to come back next year. He's fine with it. He says it's kind of cool knowing that 12,900 years ago, someone just like him was out there trying to make a living off the land. though they had to deal with mammoths and cosmic impacts, so maybe his job isn't so bad after all. Hit subscribe if you want to see more about discoveries that challenge what we thought we knew. New videos coming soon.